changing, so the weight of the compressor is to the right as it's been indicated. So you have here a load of 3,000 pounds at the 2 feet distance and 3 feet distance, and that causes this wire to go under tension. So you have here a tension in this wire, tension in this wire. That one was at wire 1, so I'm going to call this one F1. This is F2. You put it here, but this wire is under tension. We discussed that many times, because if you put the wire equal and opposite, we never show the length of the wire. The length of wire actually is 5 feet. Is that correct or not? Yes? The wire holding this beam up. Is that correct or not? It's like that. However, a couple of people decided this was the only road, because they underlined the number there, and I mentioned it in class. There is also, this is the weight of compressor sitting here. Is that correct? Or there was also a weight of the beam, but of course everybody knows that the weight of the beam, which was given 800 pounds, will go at the center. That's right. Okay, so that goes 800. By the way, those who make that mistake, I still give them lots of credit, but the rest of the problem should have been correct. If you forget about this one, you probably missed a few points, 3 or 4 points, I don't remember. But the rest should be everything according to the balance of your system. So therefore, because that was overlooked. However, this, you cannot do it any other way. I have cases that they put here AX, AY, DX, DY, CX, CY, all sorts of strange things. Is that understood? Those are not warranted for this class. Anyhow, this is this equilibrium. So you can use, this was point A was given. This was point C was given. So therefore, you can take the moment about A or about C. I don't know which one I used here, so I use it for A, so you get the code. So then you will write 800 times, this is 2.5 and 2.5, 2.5 feet, and it's going to be negative, minus 3,000, as simple as that, times 3, which is like that, plus F2 times 5, because the total length was given 5 feet. We don't have to convert that to the inches at this one, because they are all feet, foot, so they cancel each other. So you solve that problem. F2 end up to be 2,200 pounds. And then the funny part is somebody wants to calculate F1. There was a couple of people, because there were similar problems, not exactly the same problem with to the other class. Then there or here, I don't remember. Then to calculate F1, they took moment again about point C. Why do you do that? Of course you can calculate that, but this is a little bit funny. Everybody understands that the rest of it is the equilibrium. The sum of the forces must be equal to 0, so you don't have to take moment. That's extra work, but if you want to do it, that still is okay. But you write sigma Fy equal to 0, sigma Fy equal to 0. That gives you the other force. All you have to do, add and subtract, which is much easier than taking moment. Anyhow, so F1 becomes the balance of 3,800, which is 1,600 pounds. 3,800 minus 2,200. So those are the forces which should be no problem for anybody in this level of the work. Then I asked you question number 1 and 2, which you have somehow used it, but you use different format, but I show you the quickest way of doing it, which the easy way. First of all, I asked you to calculate sigma in each, which we have to calculate the area. Anyhow, the area of both of them were the same, so the area was equal to pi times 0.3 to the power of 2, or pi over 4.6 to the power of 2, depending whether you are using radius or the diameter. But notice here, you should go at least to, this is something you are not following. Some people put their number with 4, 5, 6 digits there. It's decimal point, I'm sorry, for 5, 4, 6 decimal, big number like that. Unwarranted, this is not what we do. We are going to stick to 3-digit accuracy. So you have to use 3-digit or maybe 4 or 5, but that's it. But here, you should not write it 2.8, for example. This is less than 3 digits. You should put here at least 3 digits to 2.83 or 2.28, actually 2.6 if you want. Anyhow, this is the area to the minimum of 3 digit. We learned that in the static. So that would be your area. Then you calculate sigma. Of course, sigma 1, which is the force. The force is 1600. You see how simple this is. This was really a Troy. That's what I said. You don't get too many points for doing this because the formula was given. All you have to do, calculate this and put it in the formula on top of the page, divided by area, 0.283. So it comes out to be 5,660, for example, or something similar to that. If you do it digit accuracy, that's PSI. And then you calculate sigma 2. Sigma 2 also equal to 2,200 divided by 0.283, which become equal to 7,782 PSI. With enough accuracy. Either way you went a little bit up and down, doesn't matter. Depends what you put for the area. Is that correct or not? Yes? Now I ask you to calculate the epsilon. Now many of you at this stage went to calculate delta. Of course I need the delta for the next part. Everybody understand that. However, there is an easier way that not many people use that. Few people did actually, not all. There is an easier way to calculate epsilon, which is the strain. Yeah, a strain at the same time formula is given. Notice the strain is equal to delta over L. Yes or no? But at the same time is equal to sigma over modulus of elasticity. And you already calculated sigma, so why do you want to calculate delta? If delta is not needed, if the question 3 was not there, you didn't have to calculate delta. Everybody understand that? So please pay attention to this detail. So for this part, as if I don't need the delta, so epsilon 1, which is the strain in wire 1, will be equal to sigma 1 divided by modulus of, according to the Hooke's law that we discussed. I said this is very important. So sigma 1 is given 5,660 psi divided by E1. E1 was given equal to 15 times 10 to the power of 6. Now you have to be psi over psi. So other words, it will not, because epsilon doesn't have a unit. Many people put inch there or millimeter there or whatever. That is, everybody see what I'm talking about. Some of you are not following the unit. Epsilon is the ratio, is the amount of deformation per unit of length. So it's length over length. Everybody understand that. It's inch over inch. So therefore, this drops out anyhow. And then many of you come up with 0.00 or you use 10 to the power of -4, -5. This I said do not use that. Actually, the unit of epsilon, I mentioned it in class, is micro. Micro is 10 to the power of -6. So I would rather you, so if you wrote it like that, it is okay. Everybody understand that. But this is hard to read. Actually, you should write it 377 micro. Micro means 10 to the power of -6. This is how I mentioned it before. So you buy a car here. The speed is not in foot or inches. The speed in mile. Yes or no? You buy it in euro. It is in kilometers. So that's the unit, standard unit for standard unit for epsilon is micro, because they are too small to put too many zeros there. Is that? So it's easier to keep track of them. Same way epsilon 2. However, you wrote it like that, you get full credit, because as I said, to solution manual, do it that way too. Epsilon 2 is also equal to sigma 2 over E2. Got the other material, which we have it there, 7,782 psi divided by E was given the same. Yeah, this is the same material. Actually, yours was simple. The other class, they have different problem, but they have different material too. So here the same E, so it become equal to 519 micro. Then this part has, I don't know, 10 or 11 point, I don't remember exactly. The main part of a problem, really understanding of problem, is part 3. Is that part 3 is the one that gives you the real application of this problem. Obviously, both wires are going to stretch, yes or no, downward, correct? That we have to calculate. Therefore, I have to calculate delta 1. Delta 1 is the amount of stretching of wire 1. Now, you can use PL over EA. Remember, many of you are stick to that number, but it is easier again to use now that you have epsilon. The epsilon is the amount of deformation per unit of length. Why don't use the other meaning of epsilon? Epsilon equal to delta over L. Actually, when I drove formula for PL over EA, I combine these two equations to get to PL over EA. Everybody understand that? So why not use it? Not many people did that. So delta 1 is equal to epsilon 1 times L. Epsilon is the amount of deformation per unit of length. I have to multiply it by length by definition. Is that correct or not? So this was, either ways you get credit, but I'm saying that this is much simpler. So therefore it become equal to 377 times 10 to the power of minus 6 multiplied by the length. You do not express delta in foot or in mile. You express it in the smallest unit, which will be inch. Is that correct or not? So therefore we'll be multiplying by 5 foot by 12, but again, if you make it in foot, I gave you credit, but it's not familiar number. It becomes 0.0226 inches, very small, 200 of an inch. This is something you don't see with the eye. Is that correct or not? Yep, which I mentioned that as well. So anyhow, and delta 2 the same way, epsilon 2 times L2, so I should put there in the L1 as well. So that one become equal to 519 times 10 to the power of minus 6. The length of the second was 3 feet, so 3 times 12 inches. So this is in inch. So therefore, it becomes equal to 0.0187 inches. Okay, that's part A and B. Just practically, after you do the static, all you have to do, plug those numbers into the formula I gave you. Is that correct or not? Now, here is the key that many people misunderstood. Some people put C upward, put downward, this like a pivotal. Obviously, both wires are going to be stretched. So this is the system. This is the rod before the formation location because it was horizontal. Now this is going down. How much? This is an exaggeration, of course. This is very, make it, of course, this is, which one is larger? I'm sorry, this is the opposite to the other class. So this one is less than the other one. Is that correct or not? So therefore, this goes more and that goes less. Is that correct or not? Yes? This length is 0.0187 inches, or this height. This is the stretching of the wire 2. This is the stretching of the wire. So this is point C has gone to C prime. This is point A has gone to A prime. You can call it capital delta, or this again is equal to that. Is that correct or not? Because the amount of stretching, which is 0.026. So as soon as you draw that, the rest of this problem become a geometry. Many people did not draw this correctly, or they did not make that, they did not see it this way. Is that correct? They calculate that because the formula was given. But you have to see this is what's happening. Yes? All right, now where are we? Now, if we are anywhere, we are here, we have this, you see, this is the height you want. So where we there? We were at this point. This is 2 feet and this is 3 feet. And we want to calculate, let's call this one point, for example, E, going to point E prime. I need this height. How do I calculate that height, which has a little geometry? I mentioned it in class, but I didn't do it for you, and that was a little problem. So here it is. So you draw here a straight line, yes or no, correct? So you need to add this portion of that to this portion, because this is a triangle. I can use the slope there. Is that correct or not? There are many ways of doing that. All of them are geometrical. Is that correct or not? Yep. So all I'm saying that this E prime, or the movement of this compressor downward, was equal to point delta of the compressor is equal to 0.022. Oops, sorry, no, this is the other one. This is equal to that 0.0187 inches, because this goes down equal all the way, plus this little piece. Yes, what does that little piece amount to? I need the difference between these two. Is that correct or not? The difference between that one and that one is this length. Is that correct or not? Yes, so this one, this from here to here, is 0.0226 minus 0.0187. Is that correct or not? Yes? Correct? So I need that quantity, which become equal to, I can show it to you, it become 0.0039 inches. Very small quantity, still you need 3 digits. So I need 0.00390 inch. But does all of it goes to B? Of course, that this is here. Here is this much. Here is 0. So I have to use a similar triangle of that. So because this is 2 feet and the other one is 3 feet, so I need 2/5 portion of it. Is that correct? The ratio, using the ratio. So I need multiply that by 2/5 multiplied by, because if it was at the middle, I would take half of it. Everybody understand? If it is in 2/3 distance, I get 2/3 of it, 1/3 of it. But here is the ratio of 2 to 5, not 2 to 3. Is that understood? 2 to 5. Is that correct? So that's a little geometry that you add. You have to add that together, and that become equal to 0.0226 inches, or you can write it equal to going to 3-digit accuracy as usual. So that's the answer. Okay? Okay. Now I have to move a little bit faster today, because in order for you to be able to do all your homework, there are lots of concepts going here. Because idea of determinate and indeterminate was introduced to you last time, yes or no? We are going to go through indeterminate problem. There are a few concepts here, and you have to pay particular attention. Please listen carefully, because quite frankly, if you don't get that static right, I'm worried about how you are going to handle this lecture today. You will see what's coming now. So let's go quickly into the several issues here. The first part, which is the most important part, which is the new idea, which I haven't talked about it, is the effect of temperature. So please write it down. What's the effect of the temperature, and how we are going to handle problem with the temperature, which is very important. Everybody is facing it, depending whether you are here or in East Coast or in somewhere hot like Texas. We have to take into account the effect of temperature into our system. Yes. So to do that, so this subject today, which is the new idea, is temperature. So therefore, here we have. So we are going to again take our rod, because this was our rod. There we are talking. And we are going only to consider the effect of temperature on the length of the rod, because we are assuming the rod is very long and very narrow in cross-section. Obviously, everybody understands the effect of temperature will be on the other side too, but this is too small to consider. Everybody understands that. So we are talking about the length only. So now, if this rod doesn't have any load, let's say that we build it, let's say here in the temperature, we call it TO, the temperature or build where it's being manufactured, and then we take it somewhere that goes to temperature T1. Notice T1 could be larger, could be smaller. Therefore, we have a delta T equal to T1 minus T2. Let's assume that is now larger than 0 for this discussion today. That means it is going to expand. So the temperature increases, the item is going to get a little bit larger. Everybody knows that. Is that correct? How do we calculate that? So if we are assuming the length of this rod is L, notice the area does not in the picture, we are not considering it. And after temperature goes from T0 to T1, this is going to expand this much. So this we are going to call the delta still, because this is the formation. But we are going to put a subscript T, because this is only due to the temperature, not due to the load. Everybody understands that. Previously, we were talking about load, now about temperature. Okay. What this delta T will be dependent on? What do you think? Of course, will be dependent on the value of temperature. The more temperature you have, the more delta you have. Is that correct? So I should put here delta 2 in my formula. What else will be? This small delta will be, it will be dependent on the length. The more length I have, more, so I have to put L here. Is that correct or not? And then what else? Type of material, yes? But obviously, concrete is not going to behave like a steel or like plastic or this and that. Is that correct? That one is the new parameter. This you want to write it in your note. This is alpha. Okay? We see that every time we are going to a new subject, give you a new parameter. This is property of material. That's why we call it the strength of material. Previously, we had modulus of elasticity. Something we are going to talk about next week or Thursday, I don't know when we get there, is modulus of rigidity. Now, this is something new. This is about the temperature. It is called, please write it down, coefficient of thermal expansion. So alpha is coefficient of thermal expansion. It is in the handout. It's the last page of handout. If you want to take a quick look at that one, go there. After modulus of elasticity, you see modulus of rigidity, the last page of your handout, last page. Here in the table, and near the end in the last column, it says coefficient of thermal expansion. It's given 117, 120, 10 and a half every time. But it is very small quantity. But the meaning of that is the most important. Now everybody, see, this is the whole thing. Many people concentrate on this formula. I forget about that. Let's concentrate on alpha. Now what's the definition of alpha? The name of it, coefficient of thermal expansion. Well, what is it? If I understand what alpha is, I don't need the formula, I want to tell you. So this is the definition of alpha. Write it down. Alpha is the amount of deformation. Alpha is the amount of deformation for 1 unit of length. I was writing it down, my friend. Okay? Alpha is the amount of deformation for 1 unit of the length and 1 unit change of temperature. Okay? So if I have here 1 inch of this material, look. Now you have written it down, just listen to me now carefully. I have 1 inch of this material and I put it in 1 degree change, I will get the alpha, yes? Now, of course, if I have 20 inches, I have to multiply alpha by 20 by definition, yes or no? And instead of 1 degree change, if I go to 30 degree change, I have to multiply it by? Oh, that's your formula. Is that kind? Look what happened. The formula came from the definition of alpha. Alpha is the amount of deformation for 1 unit of length, something you never, guys, you never pay attention. You always put the formula, try to remember the formula, which you are going to forget. Yes? No. Only remember the alpha, correct? Now look, alpha is the amount of deformation for 1 unit of length and 1 degree temperature, correct or not? I have 20 degree change temperature, I multiplied by that. Is that I have, instead of 1 length, I have 20 item, 20 inch or 20 millimeter. Is that understood? Yes? So this is the amount of the change that requires for you to calculate. Having the alpha defined for you. Alpha like epsilon. That's why I gave you the practice of epsilon in your homework. If you know the meaning of epsilon, this comes to you automatically. Epsilon is the amount of deformation for unit of length. I multiply it by length. Is that correct or not? That is the way you should remember this stuff rather than trying to formulate everything for you. There are few parameters, E, alpha, this sort of thing that you should, epsilon, which is very important, sigma, the same thing. Now, I have here an item. I put it there under temperature change. Obviously, it's going to, this is your first exposure. This is example now. I'm not going to use number there. I'm going to do another one, which is a little bit more sophisticated than that. But this is the idea here. I'm going to present the idea to you. Then I'm going to use it in different format. Here is the item. It's going through the temperature, the length of that L. I give you everything. And so, of course, it's going to expand. Yes? That's no big deal. So you can put it delta equal to that. Is that correct or not? However, if this is a wall here, and here is also a wall there, is that correct or not? And I have an item like that, and then I increase the temperature from T0 to T1. So let's say again, we are always for discussion, remember, this could be going larger or smaller, either way. But at this time, we are assuming that delta T is positive. Is that correct or not? So it is increasing the temperature. What's going to happen? What? If I increase the temperature, what's going to happen to this rod? It wants to push the wall, yes, but wall is not going anywhere, yes? Right? So what's going to happen? Buckle. Or it's going to be, before it buckles, it's going to be under tension or compression? Compression. There is a force created in the wall, yes? So the rod wants to kick against the wall kicks back, yes or no? So this item is under compression. How much force? We don't know that. So that it becomes indeterminate. Is that correct? Because I have no idea how to calculate the force. Is that understood what I'm saying there? However, to use this one, especially for this kind of problem, we use this, write it down because I'm going to use that for the other problem as well. There is a method, we call it superposition method. This is very important. Superposition method is one of the most strongest technique. We are going to use it for even computer programming later on. It's all depend on the or the superposition method. The superposition method is this. This has become, in a way, indeterminate problem. We do this. The reason it's become indeterminate because it's not free to move. Is that correct or not? Because of the two walls here, it was not free, so it becomes impossible to solve. So we are going to do this in two steps now. In a step one, remove one of the support, either one of them. Because usually there should be two. If it is one, there is no problem there. Because if it is, now we have two supports, support A and B, which keep this rod from expanding. And find delta. Of course, this delta from this problem to another problem keep changing. But this is what we are going to do. So this is the technique. It's called superposition method. And we do this. Okay, step one. All right, this is step one. Free. Now, notice there is no wall here. So this rod is free to expand, and I can calculate that. Delta T equal to alpha. Alpha will be given L, and delta temperature. So it goes like that. That's the step one. As if it is determinate problem. Yes. However, according to this problem, there should not be a delta there. So what should I do in the step two? I should push it back to get rid of that delta, because I want the delta to be equal to 0. Everybody understand that? Because in this one, temperature is go there, but there is no delta here. Everybody understand? See what? So step two, push back and find the force and find the required force. This is in general. I'm going to explain it in different problem because I want not to repeat it. Required force. Now, the required force is this. I have now this temp is given to me, let's say 0.01 inch or whatever, and I want to get rid of that. I'll have to put here a force F there. Is that of course? And as soon as I put a force there, there must be here a force equal and now. Delta is given, F is not given. So I have to use delta equal to delta T equal to FL over EA. So the only unknown will be the amount of force. Is that understood? Yes. Now this technique, which is very important, is going to be used for lots of other problems as well. So don't forget about that. We are going to use that again and again and again. But the idea is change the indeterminate beam into a determinate beam. So there is going to be some sort of delta there, and then get rid of that. Is that correct? By pushing back or forward. Notice if this was temperature going lower, this wants to go shorter, and you don't let it, so the item will be in tension instead of in compression. That will go from problem to problem with this. But the idea is there. Now, to practice this quickly, I'm going to put here one example here. Unfortunately, I don't have a smaller problem. This has a little bit longer, but that's okay. It gives you the idea. It takes a little bit, few minutes longer, but let's see whether we can finish everything on time. So here is your first example here, which is not in your handout, so you want to write it down. It's a three-part. I'm going to go a little bit fast here. So here it is like that. So it's not one piece, because one piece is very simple. I already calculated that. And it happened to be between two walls. In other words, it's not moving at all. And then the length here are given. This is 4 feet, and this is 6 feet. So let's go A, B, C. That's A, B, C, D. AB is 4 feet, BC is 6 feet, and CD is 3 feet long. And the diameter are given. This is 12-inch diameter. The other one is 8-inch diameter, and this is 4-inch. This is just throw you. I can give you the area separately, so we can go from there. You don't want to wait down here. Now, what we need here, this is made of aluminum. There are different type of aluminum, but it's given here. It should not. This is bronze, and this one is a stainless steel. I call it SS. So this is a stainless steel. But I have to give you all of that. So for this part, I put it here. Alpha of the aluminum is given equal to 12.8 times 10 to the power of minus 6 per degree of Fahrenheit, because that's our system. If it is in metric system, it would be per degree of Celsius. Everybody see what I'm talking about, but it has to have the unit there. So it means if I have 1 inch of this material, for 1 degree change is going to, that's the change in that. Is that correct or not? Yeah. Although we need the E, although it is not apparent here, but for the second part, step 2, we need the E. So E of aluminum is given equal to 10.6 times 10 to the power of 6 psi, which is the modulus of elasticity. Similarly, I have to give you for the bronze. So alpha of the bronze is equal to 12.8 times 10 to the power of minus 6 per degree of Fahrenheit. E of the bronze is given equal to 10.6, it's almost the same, times 10 to the power of 6 psi. And finally, I have to give you alpha of the stainless steel, which is 9.6 times 10 to the power of minus 6 per degree of Fahrenheit, and also E, which is 28 times 10 to the power of 6 psi. The length is given, the area, we can calculate now the area. The area of the aluminum, I've just bypassed that because this really we don't need that. It's pi times 6 square is equal to 113 inches square. Area of the second one, area of the bronze is equal to 50.2 inches square. And area of the stainless steel is equal to 12.6 inches square. So those are all the number we need there. These are really waste of time. Remember that this alpha, I could have kept that out by giving you a handout, but I didn't have the handout there. Anyhow, now I want to use the superposition method, yes or no? So by using a superposition method, everybody see that. I'm going to keep that because this is for your first exposure, and do it here. Hopefully, everybody can see from there. So that is auto delta T. First, we are removing this as if it's not there. Yes or no? So if I remove that, this is free to move. Yes? So delta total will be equal to delta of AB plus delta of BC plus delta of CD, because all of them are going to go through the expansion based on that equation. Yes? I have to use alpha 1, L1, delta T is the same. Is that now, for this problem, let's see how much temperature change we have. So the part of the data, we went from 70 degree Fahrenheit, we went to 170 degree, let's say the factory temperature or room temperature when this thing was manufactured. And we went up to 110 degrees, so we have a delta T of 40 degrees. Because we want the change in temperature, not the temperature itself. Correct? All right. Now, can we calculate this delta AB and BC? Is that very simple? I don't have to do it for you. Is that correct? And all I have to use alpha 1, L1, and delta T, which is the same. I do one of them. The rest, I leave it up to you. So here we go. So delta total become equal to alpha for the first one, which is 12.8 times 10 to the power of minus 6, multiplied by the length. The length is 4 feet. Of course, you never do it 4 feet because we want pound per inch square, etc. So you have to multiply 4 by 12. Some of the issue you had with the quiz, some of you had with the quiz. And then times the delta T, which is 40 degrees. So that is delta AB, correct? And then you add to that delta of BC and delta of CD, which is a similar number. Is that correct or not? So I'm going to bypass that because that's waste of time. Everybody understands that. But I give you the answer. So you calculate similarly delta BC and then similarly delta CD. The only thing changes is the length changes, the alpha changes, the delta T the same. Okay. The number are the following. I need the number for the future reference. So delta total equal to 0.0248 plus 0.0276 plus 0.0138 for a total of 0.0660 inches. Still, they are very minute, remember that, because some people ask me later, will ask me later on, eventually, should I add this to original length? We say never, because we are using the 3-digit accuracy, this length are too small to consider. Everybody see that? There are 72 inch 0.02. That's beyond the 3-digit accuracy. So you never change the length. You always assume the original length for all the calculation. Is that understood? Although they are there, they are helping us to solve the problem, but they are minute. Is that correct or not? Yes? Very small quantity. You never see this column to go down a little bit, do you? No, I hope not. Do you follow what I'm saying? That yes? All right. So now what do? That was a step one. Step one, what I did here, which I didn't show it here, you want to systematically show it that this is what I did. There was no wall there. That was the step one. Is that correct? In other words, I removed the wall and let it expand. Now, how much expansion do I have here? For total are 3 of them. This is by exaggeration. This is 0.066 inches, which is the sum of the 3, yes? However, this should not be there. Is that correct or not? So what do I do in step 2? Step 2, push it back. I already told you because this problem is simple. Then I push it back. So as soon as I push it back here, I need an FD here, which is really at point D. And also here, there will be a F, but that one will become equal. And all 3 of them are under compression and of FD. So I can now calculate in reverse, which I'm going to put it in color. Notice they are all in compression. So they're all negative, but I bypass the negative. So I'll put it positive. But 0.0660 inches equal to change in this one, change in that one, change, because all of 3 of them are going a little bit smaller, yes or no? But what is that here? This one is F of, because F is everywhere. Internally, everywhere we have F. Is that correct or not? Yeah. So therefore, FD or whatever you want to call it. Let's call it F actually. Why should we call it FD or F? That's F times the length, the first length. The length, the first one is 48 inches divided by E of the, I put the number there because later on you can plug it down. E of the aluminum, A of aluminum. Is that correct or not? Which is given to you, correct? So the only unknown is F, correct? Because this is aluminum. This is aluminum, this is bronze. I'm just calculating that one, yes or no? Then I have to add to that the change in the length of bronze, because all 3 of them are going to get a small plus, but the force is constant. Force is the same. Force. What's the length of the second one? The length of the second one is 6 feet, so it is 6 times, maybe I should write it like that. This was 4 times 12, so 4 feet times 12 inches, divided by bronze. So I have E of the bronze and A of the bronze, all given number. There's the only unknown is the value of F. Is that correct or not? Plus F times the last one. The last one is only 3 feet, so 3 times 12 divided by E of the stainless steel and A of the stainless. All number is given to you. So can you find the F? Yes, so that's we can. You solve for the F, and F's end up equal to 277,690 pound, or equal to 277.7 kips. Or you can go even to 3-digit, call it 278 kips, which is lots of load there. Then you can calculate now sigma, then you can calculate now. Now, before I go any further, because sometimes we ask in the book, they ask this question. Notice after we do this back together, A stays in original location, yes or no? It doesn't move at all. D doesn't move at all, yes or no? Because when we expanded, then we got rid of the expansion. But do you think the B stays in the same plate or B moves? Moves, correct. How much would move? Can you calculate that? Yes, you should. If you understand what I did here, in the first place, B moved that much, yes or no? That is the delta of this one. Expanded to the right, yes or no? Coming back, it moves this much. Yes, this was negative. These two are not equal. Everybody, the total are the same, but everybody understand that. So if somebody asks you what's the movement of B, you say it is this minus that. Is that understood what I'm saying? Yes, correct? B moving a little bit because temperature is not the same effect at F. Everybody understand? F is the delta F is PL over EA. The other delta is depend on alpha, has nothing to do with each other. So there is a possibility that B moves to the right or to the left, depend which one is larger. Everybody, but for this scenario, step 1, it goes further up. Yes or no? Step 2 is coming back. All the two numbers are there. You don't have to recalculate. Unfortunately, I don't have this number. If you calculate this number, this becomes similar to this, maybe a little bit less. If it is less than that, then it's moving forward. If that one is larger, it's moving backward. Everybody understand that? So that answer can be that. You are absolute. Just use the same number as you have it already. Correct?
Yes.
Yes? Can you calculate the movement of C? Of course you can. Then these two go forward. These two go backward, which should be equal, and to the third one. I am not going to go any further into detail of that one because I don't have time. Okay, now look at problem number, one of the handout problem, temperature problem. We are not going to do it. I'm going to explain it to you. There is a temperature problem with a needle there, which is an old. Right now, your temperature gauges are all digital. This is the old system. Do you see that problem number on page 5, question number 1? Did I ask you to do that as a homework? No, you haven't seen. No, I did. No, probably not. If you don't remember it, then probably I didn't give it to you. Question number 2 is a little bit sophisticated. Don't worry about that one. But question number 1 on page 5 is, I'm bypassing question number 2 because of lack of time. But question number 1 is easy. Can you tell me what's going to happen there? Or what's the idea behind that problem, knowing today's lecture is about temperature? You see those two vertical rods? First of all, the horizontal rod, which is supposed to be rigid, that they want ACE. So I'm going to put it here on the board for the benefit of everybody. So this is the idea there. That we have. Okay, this one is a rigid bar, so it has a needle on top, so it goes like that, the head there. And there they are pinned, so it's not fixed. This side is fixed. And there is another bar here also like this, pinned and fixed here. But these are two different materials. This is 1.5, they said 1.5 inch here, this is 1.5 here. This is actually a gauge for reading the temperature. So they are given all the dimension, et cetera, that you can see it in your handout. I just want to point out to you what's going to happen. As soon as the temperature rises equal to delta T, what's going to happen? If these are the same material, they are having the same alpha, the same length. Of course, both of them are going to go the same amount, yes? But that's going to defeat the purpose, yes or no? So one is going to be, for example, aluminum. One is going to be bronze. Is that correct? Or are they going to behave the same? Well, that's for the discussion purpose. I'm not using that example, yes or no? I'm saying that if they were different material, they are going to go differently, yes or no? One is going to go a little bit higher than the other one. Which one goes the higher one? Because they are if they are the same length, the same cross section, everything the same temperature change, the only thing that comes into the picture would be alpha, yes or no? The more alpha you have, the more change you have, yes. Let's say that the second one or the bronze one has a larger alpha, or this one has a larger alpha. So this one goes up a little bit. This one goes a little bit higher. So this gets in angle. So if you calibrate here, that's your temperature reading. Yes? Depends how far it goes. So ahead of time, they go calibrate there. So this becomes a gauge for you. Is that understood? That? So all you have to do, calculate this is delta T of aluminum. This is delta T of bronze. And then you can calculate how much this goes up and down. But that was the idea behind it. Whatever question is there, you can answer. Because that line now it's become like your quiz. Instead of being horizontal, it is in angle. If you can calculate theta if you want, you can calculate the slope of it. Everybody see that? So you put here calibrated ahead time. If you go, then you can read the gauges. Old gauges that we were using was this type. Now everything is digital. Yes or no? Correct? All right, that's another idea. Now, the last idea that I want to present today has really, really important, and people traditionally, students have problem with this one. Now let's understand what's going on. Before I do that, I'm going to ask you a series of questions, because I have done this enough to know that the student usually get to this type problem, which is problem number 41 in your homework assignment. And there have been questions in the finals or quizzes, etc., etc. And traditionally, students have problems. So before I start that one, I'm going to show you here a little problem. Where should I put it that I don't need the board? So I put it in this corner, that corner. Guys, write it down, all the following. These are a series of questions which are already, some of you, this is repeat for you, so do not worry about it, because if I don't get this understood, I'm afraid the idea there will be getting lost. So I'm going to put here a two-piece rod, different length, different material there. And I'm putting here a 30, this is so simple, you don't have even, I put here 36 kips load there at the end of that. This is obvious to everyone that rod AB and rod BC, both of them are under tension of 36. Is that acceptable or not? Yes or no? So in other words, when you cut it here, you see a force of, internal force of 36 in tension. So write it down here, 36 K in tension. And when you cut it here, it is 36 K of tension. Now I'm going to change the problem to something different. So if I change that one, the structure is the same. This doesn't change. ABC is exactly the same. But now I'm going to put here 18K here and 18K here. What's the force in this member? Everybody quiet? What's the force in that member? 45 students saying that. I'm asking a simple question. If we don't understand that, then we have lots of problems with the next set of ideas there. Is the force there 14, 18, 36, or 0? 0. You see, still, when I say 0, something, what did he say? Do you see any force there? Okay, what we just did here, which is very important. Yes, what we did here that you guys don't see it, I don't know why, but that you should see it right away, is this. Come on, pull this one. All right, smile too. All right, that's the whole thing. See, the whole rod is under tension. Okay, now, my friend here, don't put your head down. Here, pull it from here. Pull it that way. You see that? This side is under. This is getting a free ride, but nothing there happening. It tension because this is moving. Is that correct or not? So what's the force in this member? 0. Thank God. Okay. All right. The internal force here. Notice how important this is when you are going to make. If I put here a complicated problem, everybody get lost. That simple problem, first you have to set it your mind correctly. I cut here, cut here, cut here. Everybody see there? There is no force there, correct? This is the n. N here is equal to 0. Agreed or not? What is the n here? That no brainer either. That's the n here is how much? 36. Is that understood when I do that? There's 36 K in tension, correct? Now change this to another format. See, if you don't get this simple one understood, it's no sense for me to show you a more complicated system. Is that correct or not? Now here we go to the last one. Already I talked about all of that, and I give you problem number 3 in your previous set of homework. Everybody got 20 out of 20, but I leave it up to you to see how much you understood from those problems or not. That is the key for me. So if I put here 18K here, and 18K here, going this way, which is at the center. 18 and 18 means the load is at the center. Everybody understand what you are doing there. And now, this time, I put here 10K here. Now, what happened? So again, this is A, B, and C. What's the force in member BC now? Internal force I'm talking about. What is the internal force by cutting and looking at the free body diagram? What is the internal force in member BC? Obviously, it is 10 in compression. Very good. So here it is 10 K in compression. And what is the force here now? Because we have practiced that one. The force here, it will not be 36. Don't tell me 30. If you are taking something, you are not paying attention to all of it. It's 36 minus 10. It is 26, which is equal to 26 here. Everybody understand? And tension or compression? Tension. Because when you put here 26, and then you look at this one, but you just go. You see, this is the whole idea here. This is 26. This is 26. And then when you look at this part, which looks like this, so I want you to understand, this is 10, this is 18, and this is 18. Still, this is 26. But people look at this, they think, this both of them indicating it is in tension because they are going away. Is that correct or not? Yes? So it is 26 in tension. Yes? All right. Now let's talk about the real problem, which is similar to problem your 41 in your homework assignment. There is one gentleman here, this class already, he did it. I said, if you did this problem, that was my statement, by yourself without taking this course before, you should have no worry about this class. So you are going to pass this class, if you can do it. But let's see everybody understand this or not. Here is the problem. So this is a problem similar to your homework assignment, not exactly the same. I purposely choose one which is similar. So there is a rod here, which is aluminum. And then another piece here, which is a little bit larger in dimension or in area. And this is put here an 18 kips load at this point B. So this rod, there is a rod AB, there is a rod AC, and there is a rod CD. And then at this point C, these are all central. The way I show it here, this load should be at center or should be 9 this way, 9 on the other side, but we don't have time to do that. So I'm putting here 14K here. Notice if this was the problem, one more time, with reference to what we just did here, what's the force in this member? The force in this member would be 0. The force in this member would be 14, tension. The force in this member would be both of them on one side. Both of them will be 32 in tension. Everybody understand that? Yes? Okay, but that's not the problem, unfortunately. Because if this was the case, this problem will be determinate because you can calculate the delta. Yes or no? The problem is this. That side is already a wall. I'm going to put this side against a wall, and it is attached to the wall and is not moving at all. So wall A and wall D are not moving. So what's going to happen? Or is there going to be reaction at D? Yes. Is it the reaction at D equal to 14? I have seen lots of it. Is it going to be equal to 14? Yes. Look what happened to the other problem. The rod are going to kick against the wall, and wall will have a reaction there. Is that correct or not? So if I remove the wall, I should replace that with a force. Is that correct or not? So here it is. So I put it there for you to see. Therefore, I keep it there just as. There is a reaction of RD. Yes or no? Yep. Because it is against the wall, and somehow this rod maybe wants that way. I just put the reaction against the action. Because action is to the right, I'm assuming the reaction is to the left, most likely. I don't know yet. Is that correct or not? But is it the same thing happening at A as well? Yes or no? Because the A is also, the rod is attached to L. You are pulling it or you are pushing it. There should be a reaction and RA. Everybody sees suddenly what happened. Previously, when it was determinate, these are all determinate. The reaction is there, understood, because that is equilibrium. Everybody understand what we put here? Look here, 18, 18. Here you put 36. Everybody say, here you put 36. Here you put 26, which is the balance. Now I have a problem, which is technically it is indeterminate because I have two reactions, one at RA, one at RD. Okay, so this is. Now, your choice is when you do this problem, you can put it any direction. RA and RD does not have to be any specific direction. For this problem, because both of them, especially if this goes to the right, this goes to the left, you don't know what's going to happen there. So choose any direction you want. If the answer comes positive, means that direction is correct? If this is a static rule. If the answer comes negative, means you have to change the direction. Is that correct or not? That does not change the system. However, this problem is a little bit simpler because both of them are going to the right. I'm using my reaction going to the left, most likely scenario. Is that correct or not? Yes? So what's my equilibrium equation? Notice you don't have any sigma y, you don't have any sigma m, because these are fixed, correct? But this is still axially loaded member, so it's one-dimensional. All I can write here is sigma fx equal to 0, which means plus 18, plus 14, minus RA minus RD equal to 0, or RA plus RD equal to 32. Keep nobody argue into that sum of these two must be equal to sum of these two. Is that correct or not? So what we do end up with? We end up with one equation of a static equilibrium, but two unknown. How do we solve for R? What did I ask you to do last time? Bring the deformation into the system. What deformation? What's going to happen here? AB is going to change, yes or no? BC is going to go through the change. CD going to go through the change. The first method that comes to your mind, there is two methods to use here. One is general method, the other one is the superposition method. I already talked about superposition, so if I run out of time, you know how to do that. But I will explain it anyway, don't panic. Okay, I have enough time to explain that. But the general method is this. Because we don't know, this item going to be under some force. Yeah, this item going to be under some force. This item going to be some force. Some of them are under tension. Some of them obviously under compression. Depends how many members you have there. But the total must be equal to 0 because the two walls are there and not changing. The total length stays exactly the same. Everybody see what I'm talking about? So in general method, this is method 1. So write it down. Method 1. Which I'm going to call it general method versus the superposition method. Now, I give you sometime in the final or in the quizzes, I ask you to use your own way of doing it, which way you like better. Sometimes I specifically ask you to use this method versus the other method to check you to see whether you know it. If I were you, I do problem number 41, write it down in both methods to check to see whether you understand the whole system. Problem number 41 in the book doesn't ask you what method to use. If I were you, I do one method, then I check to the other one to learn it. Is that understood? Yes? Okay. Now, in the general method, is this total deformation. See, the delta total, everybody see what I'm talking about, is equal to delta AB plus delta BC plus delta CD, but total must be equal to 0. In other words, if this is under compression, this is under compression, this is under tension, if this goes 1 inch forward, these two must be going 1 inch to 2 together, go 1 inch. The total deformation must be equal to 0 because A and D are wall not moving. Is that correct? Yep. Okay. Now, what is delta AB? Now, in order to calculate delta AB, I have to go through this. But this is the idea here I presented to you. Now, I'm asking a question, very simple question. What is the force in member AB? What's the force in member AB? 0? RA, absolutely. Just use your logic. You say, where is there an RA there? Yes or no? If I cut it here, see, this is the, what is the difference? Here you cut it, this is 26. You said here is 26. Yes or no? I don't see why people even make mistake. Cut here. This is what we are saying there. This is RA. That's what the equilibrium tell you to do. N must be, this is N, yes or no? Internal force, which becomes a stress later on. N obviously must be equal to RA and must be in tension or compression. You got it right. Everybody see what I'm talking about? We are doing the same thing. But as soon as you see RA, if I put 10 here, everybody says 10. I put RA here, everybody looks at it. But what's the difference? RA is a force not been determined yet. Is that correct or not? The force in member AB will be equal to RA in tension. Agreed or not? Mm-hmm. Yes. Okay. So delta AB here, delta total equal to RA times what? What is the delta? Delta equal to PL over EA. Internally, that's my internal force, RA. Everybody see that? Times length. Length is I didn't give it to you? Sorry. So let me give you the, I got so excited about the idea, I forgot to give you the data. You see that after 25 years teaching here and many years teaching somewhere else, still I get excited about this. I hope you get as much excited about it. So I forgot to give you the rest of data. This is AB is 8 inch, BC is 10 inches, CD also is 10 inches. This part is the whole thing, A to C, which is 2 parts, AB and BC, is aluminum, I believe, and E of aluminum is given equal to, yes, A of aluminum is given equal to 10.4 times 10 to the power of 6 psi. And I give you the area because, again, the dimension is given 1¼ inch, 1½ inch, but let's forget about that. I give you the area, and the area of the aluminum is given equal to, area means a cross-section area. Area of the aluminum is given, depend on the diameter here, et cetera, is given equal to 0.994 inches square. Actually, the diameter here is 1 1/8, 1 inch and 1/8. So you can calculate your, and then this part is not aluminum, this part is steel. So E of steel is given equal to 29 times 10 to the power of 6 psi. Here, let's make it, and the area, again, if I give you the radius, etc., so area is 2.073 inches square. You can go 3-digit or 3-digit. So in other words, all the data is given to you. The length given, area given, E is given, etc., etc. That's not the point. The point here, one more time, the internal force here, I'm looking for that internal force. Obviously, it is RA. Is that correct? In tension mode. So RA times the length, 8 inches, divided by whatever number we have EA there. We have 10.4 times 10 to the power of 6 psi, multiplied by area, 0.994 inches square. So that would work. Is that correct or not? So that part should not be a big deal. The big deal is the second part, which everybody makes a mistake there. Now, what is the force in member BC? By looking at the forces there. Obviously, I have to adjust it by 18, yes or no? I'm coming from right. You see, this is what I'm doing. A cut here, RA. Everybody understand that? A cut here, now what do I see? RA here and 18 there. Everybody understand that? So let's draw it here. So in order for you guys to, I don't know how you handle your previous homework. This is cut 2-2. This is cut 2-2. Cut 2-2, we are here. To find the internal force in that member, yes or no, correct? But this time, I have now to worry about something here. This is RA, this is 18. Obviously, there depends on value of RA, yes or no? RA could be less than 18 or could be larger than 18. There it could be either in compression or in the tension, but doesn't make any difference. I'm going to show both cases. Then let's assume, guys, let's assume in your mind, this is 5, yes? If this is 5, this is 18, what should I put here going this way? 18 minus 5. So if I put it here, 18 minus RA, assuming RA is less than 18. Everybody understand? That rod will be under what? It will be under tension or compression? Compression, you are pushing it. Is that correct or not? So I have to write here minus, what did I write here? 18 minus RA, 18 minus RA, because that's the force, time length, the length is 10 inches, divided by the same number, 10.4 times 10 to the power of 6, 0.994, because that's the same thing. But this was in, but this is one option. The other option is RA to be, for example, 30. Is that correct or not? If RA is 30, then what should I put here? See, I put the other option here. So I put it both of them. I'm putting this in compression mode. Everybody see that? Now in the tension mode, this is 18. This is RA. This time I have to assume RA is larger than. So let's say this is 30. If this is 30, I should put here a force what? Like that. Is that correct or not? Yes. 30 minus 18, which will become RA minus 18, opposite to that. But this time it is in tension. Yes. Assuming this is 30, I have to put here 12 here. Let's see, 30 going this way, 18 here. I have to put 12 there. Is that correct or not? But this time, instead of that, I have to write underneath. I do the option. Plus RA minus 18 times 10 divided by. Is this exactly the same? Everybody see that? There is no difference between the two. Because you don't know the value of RA. It could be in tension. It could be in compression. But in tension, you are putting plus. In compression, you put minus. So minus times minus again. Because both of them is the same. Doesn't make any difference, of course. Is that correct? Because we don't know the value of RA. Something you are afraid to make a decision. Everybody understands. So when you go forward, you have to assume here whether this is in compression mode or this is in the tension mode by adding everybody or by subtracting the right figure. Is that correct? Correct. Everybody again, one more time. This is 18. This is 5. I have to put 13 here. Is yes or no? Which become in compression, assuming RA is less than 18. If RA is larger than 18, this is 30 minus 18. I have to have 12 there, 18 there, 30 here. Is that correct? They all will be in tension. Everybody see, both of them are the same. Because minus, if I put here a minus, that is as I put it here. This is in compression mode. This is in tension mode, exactly the same. Of course, the last part is very simple. The last part is what? The last part is, look at it again. What do I do for the delta CD? All I have to look here. Look at the right-hand side. What's the force in member CD? Look at, guys, what is the member? Is that the case? Like RA, isn't that RD? RD in what? In compression. This is obvious. I don't have to worry. So I have to put here minus RD times length is 10 divided by E of the steel, which is 29 times 10 to the power of 6, multiplied by 2.073, because this is the larger area, etc., etc. Of course, what is RD equal to? Remember equation what we had? What is RD equal to? RD equal to 32 minus, which you could have come from left. That's what you would see. If you don't look at it, you come here, you see here 32 minus RA. Everybody, which is equal to RD. Yes? This way is simpler, so I remove that. And I put here 32 minus RA. Everybody see what I'm talking about? Yes? So it will work. What is your unknown? Your only unknown left this is, please do not use the solution manual. So because in solution manual, they do lots of things, formula things, this and there. So please stick to your note. You should be okay. Is that, I hope that you understood what I said, especially with that explanation there. Yes? Just cut, find out your force, assume whether it's tension or compression. Is very static base. Is not that different. So anyhow, the only unknown is the value of RA. So you calculate RA. RA ends up to be equal to 11.9 kips. After you find RA, you can calculate RD. RD ends up to be equal to 20.1 kips for a total of 32. And therefore, the problem is solved. But I used a technique which I call it general method. That means the total deformation was equal to 0. Now, you want to make this very complicated, create a gap of 0.001 inch there. Yes or no? Then what do I do? I'm not going to ask you that question. I didn't even ask you to do that. I think I asked you one homework to do like that. Is that if there is a gap, then what should I do? You see, when I say total delta equal to 0, you should say total delta equal to what? 0.001. Everybody understand? Because total delta is not equal. So you can incorporate anything. If you understand the technique, guys, this is engineering work. The formula there that they are giving to you, those are all throw it out. In future, I'm going to give you lots of sigmas, lots of this, lots of for bending, for tension. People come to ME 219, and we are going to do more sophisticated problem. The only one that helps you is understanding of what's going on. Everybody are not remembering the formula. All the formula will be given to you. In this class, it's the same. In the final, I give you 2-page formula. Are we out of time? I hope not. I have the most important part is left. Now, what is the second method? The second method was Superposition. Let's say whether we can use superposition. That's why I asked you to use both methods. Some people prefer this because this is one-liner. If you understood what I did here, this is the simplest method of all. But you have to know your static and you have to know your tension and compression. I believe I explained everything I could to you. Everybody understand. But there are people that still are. If you couldn't do your quiz, sometimes I get worried about getting all of this established in your head. Now let's go. Superposition seems to be simpler, but it's a little bit longer. So this is what we are going to do in superposition. In superposition, that still is the problem. Everybody see that. So what was step one? Step one was to remove one of the support. Notice you can remove the A. Some of you will do. You can remove the D. I want to stick to the same method, so I'm going to remove the D. Is that correct or not? If I remove the D, please write it down. This is superposition. I'll put it in color. Superposition. And I'm going to remove one of the support. Therefore, this is what the number are all the same. So I'm not going to repeat the number for lack of time. So here is like this, like that. But there is no wall there. Everybody under? Is that no? That's not the right one. I want the previous problem. So here it is. I'm sorry for that. So here is a little bit larger. So let's look at like this. This is the rod, correct? This is, here was 18, and here is 14. I'll put it a little bit, K and K. No support there. If there is no support there, there is no reaction that this is free to move at D. That's the difference between the two problems, two methods. Can you calculate that one? How much this is moved? Before I do that, I have to go to that one and find out this is again A, this is B, this is C, this is D. What is the force here? Come on, guys. I hope you are not saying 18. I hope you are not saying 18. Is that correct or not? What's the force there? If you are in doubt, start from the other side. What's the force here? What's the force there? I hope you say this time 0. Is that understood that? The 14 applies at C, so it applies to A, B, B, C. Everybody understand? The force in member CD is the internal force. Look, nothing there. Is that correct? The internal force here, N equal to 0. What's the internal force here? Look at it. It's very simple. The internal force there is 14 tension, correct? So it's a N equal to 14 tension. So here, the N equal to what? 32, because you have here a reaction of 32K. Is that correct? Because that is a simple, that's a determinate problem. I gave you this problem 2 weeks ago. Okay. Delta, I'm sorry, I've losing my foot. Delta equal to what? Delta equal to delta total not equal to 0. This was delta total equal to 0. This is a step 1 of superposition equal to delta of AB plus delta of BC, sorry, delta of CD. But obviously delta of CD, as we said it earlier, is equal to 0 because there is no, it just moved because AB and BC move forward, as we showed it here. Is that correct or not? Yep. What's delta AB again? Oh, I'm sorry, N was equal to 32K. Is that correct or not? Yes? So delta equal to 32 times length, because this is 32 in tension. The number is the same. I'm not going to put the number there because we are out of time. So E of aluminum, A of aluminum, PL over EA, correct or not? For the second part, what's the internal? It still is under tension. Okay? So I have to add, not subtract. Yes? Your loading could be, your homework could be different. You see, it could be tension or it could be in compression. Remember that. Here is all tension, so plus not 18. It is 14 times 10 times E of aluminum, A of aluminum. So sorry, E of aluminum, A of aluminum, and plus 0 because the third part or CD doesn't have a system, a load there. So I can calculate. Now I have to get my superposition here. The total become equal to, I give you the number, 0.0248 plus 0.0135 for a total plus 0 equal to 0.0383 inches. So the whole system not moving, all three parts together, moving to the right this amount, which should not be there. So I have to push it back. That was a step 2. So in a step 2, be careful here. Now, many people, when they do a step 2, they put this load back again. You should not put this load back again. Please make a note of that. The only force you have is the F, because I tell you that this plus this system together, that's what the name of superposition comes. It means step 1 and a step 2 should be superimposed on top of each other, so it become original problem when they add it together or superpose together. So step 2 is this, nothing, no load on it, just. However, it has expanded this much. This is 0.0383. Everybody see that? That's that number, yes? And you want to push back, so all three of them going again to participate in this movement. Is that correct or not? So what force should I put there? A F there, yes? But technically that F, you will see, will become your RD. Is that understood? But let's do it for time being, see what happens. So here I put F here. I don't call it anything. Obviously, I have to put here a F. Now, key. Very important key, student make a mistake. I did not put any load on that one. Everybody understand it. Before I run out of time, because we are at the end of class, look what happened. If I superimpose these two together, well, let me finish first the problem, so I cannot tell that. So what will be? All three parts will be under compression up, because this is a very simple problem. So you write here like before, I put it, step 2, I put it in color. 0.0383, negative, of course. The other side are negative. We are bypassing the negative. This is under F, this is under F, this is under F. Is that correct or not? All in compression. So you can start from that side. So this is for delta. So delta AB, delta BC, delta CD. So it's F times 8 inch divided by E of aluminum, A aluminum, which is part AB, plus, as I said, these are all in compression, so all negative, but we are bypassing there. Again, F, the length of the BC is 10. It is aluminum, E of aluminum. Actually, you can, if you want, you can combine these two together because they have the same EA. So usually we do. And plus the third one, which is still is F, but the length is 10, but this time it's stainless. It was the steel. So therefore, E of steel, A of steel. Everything is given except the value of F. So when you calculate the F, F ends up to be equal to 20.1 kips. Of course, it ends up in pound, then you change it in kips. Is that understood? Now look, now we're putting together. If this is 20.01 kips, and this is 20.01 kips, now put these two together. Yes? What force do you have here? 18. What force do you have here? 0. So the sum is 18. What force do you have here? 14. What you have here? 0. So the result is 14. Everybody understand that? What you have here is 32 minus 20.1, which is 19 point whatever we got there. Everybody see that? That's the RA. Is that correct? And what is this? This technically is RD, everybody. And more importantly, here you expand it forward, and then here you expand it forward. This is you push it back. So when you superimpose these two together, you have two problems. Now, before you go, there is one problem left, which is the interesting problem. That problem, it will not be in the quiz. However, I ran out of time for the other class, the same with you. But you should do it as much as you can. You probably have some problem with one. That's it. I will tell you which problem it is. There is only one problem like that. I explain that next Tuesday. So it is a rod like that. If you put a rod like that, one item under temperature, of course, that's no brainer. Everybody can do that. However, part of it is, inside of it is aluminum. Outside of it is steel. So if you put that in the temperature, what do you think is going to happen? Can you tell me idea before you go? Just give me 1 minute. Because alpha is not the same. Yes? So aluminum, let's say we want to go further, still wants to stay back, but they are bonded together. They are going to end up in the same place. Everybody are there. So one will be in tension, one will be in. It's a complicated problem. I'm going to explain that later on. If you cannot do the homework, don't worry about it. That won't work, but will not be asked in the quiz. Is that understood? So the rest of it will be. So the rest of it will be on the quiz, so get ready for the, so if you can.